Hi everyone, welcome to a build session. I'm Adanandini, joined by Peter from Azure Container Instances team. We are super excited to be sharing product updates and upcoming announcements and offerings, and also highlight real-world examples of how customers are using ACI. I can't wait to get started. So we'll be talking about ACI at a very high level. What is ACI, its capabilities, its benefits, and how customers are using ACI for their scenarios, highlight the advantages of ACI for those workload patterns, and also share about supported features and integrations, and highlight the limitation that's been lifted recently for those features as well. Finally, we'll be talking about a product roadmap, the upcoming announcements and offerings, and we'll also end with cool demos highlighting those offerings as well. So let's get started. Azure Container Instances, ACI, is the fastest and the quickest way to deploy containers in Azure Cloud without worrying about managing the underlying infrastructure. And it is the fastest and the easiest way to deploy containers in the cloud with greater flexibility in resource allocation, scalability, and cost effectiveness, offering a consumption-based billing model to optimize costs. ACI offers scalability by allowing you to scale containers within the container group up or down based on your workload demand. Additionally, it offers a benefit of cost effectiveness, which allows users to be charged per second for the exact usage duration of the container, with no upfront cost or management overhead. In ACI, an unit of deployment is called container group, which is identical to pods in Kubernetes world. A container group provides a cohesive and manageable way to deploy containers within a container group, which are all bound by lifecycle events and compute resources such as memory and vCPU. This allows for efficient management of containers within a container group as a single unit, and makes it easy to scale up and scale resources during orchestration scenarios, and helps to manage the containers throughout their lifecycle. Users can quickly deploy Azure Container Instances using Azure's command line interface or Azure portal, which makes it easy for users to get started to deploy containerized applications in cloud. It also supports both Linux and Windows containers. And finally, you can deploy multiple containers within a container group, which enables you to deploy multi-container applications in ACI. So Azure has many offerings in the container portfolio. How do we know where to use ACI, and where does ACI fit in the Azure container landscape? Azure Kubernetes Service is a fully managed Kubernetes offering which allows you to run any type of workload from simple and complex applications, and it provides flexibility to manage your infrastructure and capacity, which includes provisioning and managing your worker nodes, your networking, storage configurations, and able to run your container workloads at scale in a managed environment. Azure Container Instance is a serverless container as a service offering, which is best suited for batch or task-based applications, and allows you to not worry about managing infrastructure but focus on building applications. We will be talking in detail about real-world scenarios where ACI is the best fit, and share recommendations for workload patterns for ACI. Azure Container Apps is a fully managed serverless platform best for microservice applications that provides an abstraction layer on top of Kubernetes or ACI. And it eliminates the need for infrastructure management, allowing developers to focus only on building applications. While Azure Container Apps is a great solution for developers who want a simple and fast way to deploy container applications, it abstracts away many of the details, and it's only designed to provide simplified deployment experience. Whereas ACI focuses on application development and also gives you the ability to modify your resources, compute resources, configure your container images and networking and storage configurations, which allows you to customize your container environment. This, as a result, makes it a better fit for users who are looking for more advanced container orchestration capabilities. The right choice depends on your application requirements, your workload characteristics, and the level of control and management you prefer. Now let's talk about what are the different common workloads and scenarios where ACI is a great fit. ACI can be used for various workload patterns, such as automated task or scheduled maintenance jobs, which can be used to run batch processing jobs such as data processing or video encoding and containers, where containers can quickly run, scale up and scale down as needed, and it can be scaled down once a job is complete, which allows you to optimize costs. ACI can be used for deploying machine learning models or build custom simulators, and it can allow you to run containers for inferencing, making it easy to scale the inferencing models based on your workload requirements. Now let's talk about how these workload patterns are used by our customers in real world and what are the benefits of using ACI in those scenarios. We're going to talk about a few examples which represent the workload patterns such as batch processing or data processing scenarios, AI, ML, training models, simulation scenarios which we described earlier, and also self-hosted CI/CD agents and burst workloads. The first customer scenario here is about a financial firm which offers risk analytics as a Azure hosted service for the global financial clients. They use ACI to run large-scale risk models to provide data and insights to manage a complex risk analytics scenarios. This firm scales up to 10,000 container groups in a period of 20 minutes, multiple times during the day. They migrated from cloud services to ACI, so due to its fast provisioning time, to flexibility and scalability, and also able to save cost to manage their growing demands of their customers. Additionally, the benefits of multi-region, the support for maximum compute resource, such as 16 GB memory and 4 CPU, was a huge win so that they can run large-scale containerized workloads. The firm is now able to pursue the largest customer in this space. ACI has enabled the firm to efficiently run their risk analysis platform, providing analytics and data to the global clients while benefiting from its scalability, flexibility, and cost effectiveness. The next example is about a software services firm who use ACI to build a custom self-hosted CI/CD agent. The application called as Cloud Manager is hosted within their customer's virtual network, and ACI is deployed within their virtual network so they can securely talk to the different Azure services such as functions, logic apps, which you see in the architecture diagram. And these services build a CI/CD pipeline, which is used by their internal customers to build custom websites, to mobile apps, and forms. ACI containers are deployed within the VNet so they can securely access resources such as storage and networking to maintain their built artifacts. And all these services are hosted behind their VNet as described in this high-level architecture diagram as well. The next example is about an internal customer which represents the AI model simulation workload pattern, which is widely used by a lot of customers because it allows the flexibility to scale up and build custom simulation models, training models as needed, and also optimize cost. Simulations are available across various industries and systems. Bonsai is a project which offers low-code AI platform and simplifies machine learning with deep reinforcement learning, which allows customers to build and train smarter autonomous systems. Bonsai uses ACI to build and scale simulators on demand for multiple scenarios. They're able to train the policy of the AI engine, scale simulators on behalf of the users, and able to build custom simulation runtime with commercial containers. ACI was chosen for several reasons, such as fast provisioning time, able to quickly scale simulators as needed, and build training models on demand, able to efficiently and flexibly train the policies, and fast teardown, along with resource optimization, multi-region support, and multi-OS support. So these benefits have enabled them to run custom simulations across different geographic locations and also serve and meet diverse simulation needs. The maximum compute resource that we offer also has been a huge win so that they can run diverse simulation use cases. ACI offers Bonsai an efficient and flexible solution for scaling simulators with rich feature sets and making it an ideal choice for their simulation workloads in diverse industries and systems. So next we're going to talk about best practice and recommendations that we've been sharing with our customers, primarily who fall into the financial tech industry because who have tight security and audit compliance requirements to meet their business needs. So we're going to share best practices on how you can securely deploy ACI in your custom virtual network and how can you meet your high availability requirements. Customers who need to meet security and audit compliance needs for production environments have to deploy ACI behind an Azure Virtual Network, and also enables support for features and integrations that should work for VNet injected container groups. We have learned the common ask of these customers who have to meet these business requirements include securely accessing the images stored in the Azure Private Registry and able to use managed entity to access keys or secrets to deploy the applications and also access the container group metadata. And also enable ACI as an Azure Key Vault Trusted Service or Azure Container Registry Trusted Service. Additionally, support for built-in policies like custom managed key on enforcing only VNet inject container groups is also a key requirement to have a secure ACI architecture. Finally, these customers also need to meet business continuity or disaster recovery requirements to make sure ACI deployments are resilient for region failovers. And recommendation for these customers who have these requirements is to deploy ACI in multiple regions, have custom solutions using products like Traffic Manager that is offered in Azure to manage failovers. And ACI does not provide any data application or automated HA between these regions. Now let's talk about the features that ACI supports and the integrations. ACI supports various set of rich feature set which span across different areas such as networking, authentication, and integrations with services like Azure File Share and Logic Apps and virtual nodes. We offer a lot of features that enable you to securely access the secrets or keys using managed identity and also securely deploy behind your custom virtual network and ensure all the features that's supported for non-VNet containers also works for VNet injected container groups. Additionally, we support various integrations, as I mentioned earlier, like Azure File Share, so that it allows you to persist the data beyond the lifetime of your container groups, mounting volumes, and then integrate with Logic Apps so you can orchestrate your workflows. And finally, integrate with virtual nodes to meet your elasticity requirements for your workloads, so you can run burst workloads based on your demand. And the other call out that we want to share here is these features, we have limited most of the security and networking features had limitations for Windows containers, and those limitations has been lifted and it works for any type of container across all the supported regions. I'm super excited about the next set of topics and we are looking forward for Peter to enlighten us about the product updates, the roadmap, upcoming offerings, and also share cool demos that represent those new offerings. Take it over, Peter.
Awesome. Thank you for the great overview, Nandini. I'm going to start off by talking about one of my favorite ACI integrations, virtual nodes with Azure Kubernetes Service. Virtual nodes is our integration with AKS, which enables customers to deploy pods serverlessly from their Kubernetes cluster. And when customers are using the virtual nodes add-on, they get all of the benefits of a serverless platform. They are not responsible for any of the underlying infrastructure management, OS patching, or OS updates. And virtual nodes is a really great fit for many workloads that run at a high scale for a period during the day. So this includes things like ML model training, ML inference, and batch type workloads, since ACI containers spin up so quickly and can be added and removed in a matter of seconds. And I'm going to go into a demo today where I showcase a model inference application running on top of virtual nodes. And in this application, I'm going to take a list of images, which is represented in this Azure queue, and process the image in order to determine what type of animal is represented in that image. So each pod deployed via virtual nodes will take the image as input, classify the image, and output the result to this queue right here. Right now we can see this queue is empty since I don't have any pods running via virtual nodes, but it'll be populated as I deploy. To start off with, I deployed an AKS cluster with one node pool, which contains one node, and then I also enabled the virtual node add-on to my cluster, so I am able to deploy pods via virtual nodes. In addition, I have deployed the Kubernetes event-driven autoscaler on this cluster in order to be able to scale up and down based on the number of items in my Azure queue. So as there's more items, I can deploy more pods via virtual nodes and can remove them as the items are processed, and if we can quickly scale up and down. I'm connected to my Kubernetes cluster here in Azure Cloud Shell, and I'm going to start off by showing there are no pods currently running in the Kubernetes cluster. We can see there's 0 pods running. And I created this Kata scale job in order to define the job and how it should react to events such as items being in that Azure queue. So I have a pod with my machine learning inference application. The image is represented right here. And then within this pod as well, I specify a toleration for the pod, which enables the pod to be deployed on my virtual node and not only on standard pods. So in order to deploy on virtual nodes, you need to add a toleration to your pod spec, and it can then be placed on the virtual node. And we've tainted the virtual node by default in order to ensure customers don't accidentally scale up too high without noticing. So you have to make a meaningful operation and actually add this toleration to use virtual nodes. Additionally, I have a min replica count and max replica count, which specifies how many pods can be running at any given time. So we can scale all the way up to 100 or scale down to 0, depending on the number of items. I'm now going to apply that Kata scale job to my cluster in order to deploy pods via virtual nodes. And as this is applied, we're going to start scaling up the number of pods running in the cluster. And we're going to begin processing actual images from that Azure queue. So we'll first start off by applying the Kata scale job, and then we'll start processing images. So if I now go over to my result queue, I will begin to see images have been processed, and we can see animals classified, such as a white wolf or an Arctic wolf, and the pods will continue to process until all of the images in the initial queue have been cleared out. So if I go back to my Kubernetes cluster now, I can see there are 100 pods running within the cluster that have been deployed via virtual nodes. So 100 pods scaled up to the max replica count. And then I can also move over to another resource group, which is going to showcase the pods which have been deployed via container instances. So as I navigate over to this resource group here and refresh the resource group, you can see there are 100 container instances representing the pods deployed via virtual nodes. And as these are scaled up and down, these container instances will be created and deleted. The next exciting new offering I'm going to talk about is Spot containers on ACI. And Spot containers on ACI are interruptible containerized workloads which run on unused Azure capacity and provide a significant discount of up to 70% for our customers compared to regular priority containers. And Spot containers have all of the same great functionality as a standard ACI container, with the caveat that they can be interrupted at any point in time. But they are great for many types of workloads, such as image rendering, genomic processing, and Monte Carlo simulations. And we're going to be posting a lot more about Spot containers after Microsoft Build. We look forward to seeing what our customers build on top of it, and we'll keep improving on this feature in the future. Another new offering we have on ACI is confidential containers on ACI. And within Azure, we've seen containers become the norm for application deployment. And we've also seen customers focus more on data privacy focused scenarios. And we wanted to make an offering that makes it easier for them to run these types of scenarios on top of Azure. And confidential computing already provides great mechanisms to support applications processing highly sensitive data, but they can be complex to use due to specialized programming models and the need for learning more about infrastructure management. And that was the motivation for building confidential containers on ACI. So ACI is already the quickest and easiest way to deploy containers on ACI. Confidential containers on ACI is now the quickest and easiest way to deploy an application into a confidential computing environment. And as you can see in the diagram here, the container group represents a trusted execution environment, which has data in use protection provided by a hardware-based in-memory encryption key. And we also provide data integrity through open source platform integrated sidecars. So customers can verify that the code that should be running in the container is actually running in the container. I'm going to do another demo here of how quick and easy it is to deploy a confidential container on ACI. So I have an ARM template here with a standard container group, and I add two different properties to my ARM template. The first being SKU, which is confidential, and the other being a CCE policy, which stands for Confidential Computing Enforcement Policy. And in this policy, I define all of the container images, environment variables, and container commands. So I'm going to use the Azure CLI to generate my confidential computing enforcement policy, which is taking the different layers of the container image, environment variables, and generating a base 64 encoded policy, which represents all of these different properties. And this is going to be automatically injected into my ARM template, and it will be validated as the container group starts up, and is also available for additional validation through the Microsoft Azure Attestation Service. So now that my ARM template is ready for deployment, I can do a new resource group deployment onto Azure, and I'm going to do that through the Azure CLI right here. So I'm taking this ARM template with my CCE policy injected, and I'm deploying this container group to Azure. And once the container group is deployed, within Azure portal, I'll see a public IP address and the SKU as confidential. So I'm going to navigate to the IP address of this container group, and we're going to see a hardware-generated attestation report. So this attestation report contains important information about the hardware, the application running inside of the container group, and this can be used to validate the authenticity of the hardware and also validate that the trusted application is running within the container group. So we have some great open source integrations with Microsoft Azure Attestation and Azure Key Vault that make it easy to validate this information and run highly sensitive applications on confidential containers on ACI. In the next slide here, I'm talking about one of the neat scenarios we've seen our customers running via confidential containers on ACI, which is data clean rooms with multi-party computation. So we've seen businesses and project collaborations often requiring confidential data to be shared amongst multiple parties. And this data is often highly sensitive. So it includes personal information, financial information, medical records, and it needs to be protected from unauthorized access. And with confidential containers on ACI, we're providing a hardware-based and attested trusted execution environment to help protect the data which is being processed. So this enables organizations to get more value from their combined data sets while maintaining control over the access to the sensitive data. And a great example of this we have seen is in customers in healthcare, where these customers are generating very large data sets and using machine learning in order to create imagery or other observations from the data. And disease diagnostic and drug development benefit quite a bit from being able to iterate over multiple data sets. And we're seeing better and better insights coming out of these machine learning models, which are using data sets from multiple customers. The next scenario I want to talk about is confidential inference, which enables model developers and data owners to collaborate while protecting the intellectual property of the model developer and also protecting the data, which is used for inferencing, and keeping that data secure and private. Confidential containers on ACI lets you process data from multiple sources without exposing the input data to other parties. And this is great for anti-money laundering scenarios, fraud detection, and secure analysis of healthcare data. ACI sidecars make it easy to integrate with all of these Azure services, such as Azure Storage and Azure Key Vault, and they're open source and available to all customers. And since ACI containers spin up so quickly and can be added and removed, this makes ACI a great platform for supporting these confidential inference scenarios. In this slide, I'm going to provide a recap of the great features we have in the ACI roadmap. To begin with, we're very excited to be heavily investing in virtual nodes. We've added 2 new features, which are the ability to pull images with a managed identity, and also the ability to run init containers in your virtual node deployed pod. Additionally, we're investing in new SKUs to meet our customer demands for increased security and lower costs for running their workloads through the Spot container offering and confidential containers on ACI. And in the area of networking, we've lifted all of the limitations on running Windows containers with our great networking features. So now you can deploy a Windows container, assign its own virtual network, and take advantage of all of the other great networking features ACI has to offer. And as always, we're building out new regions in order to meet our customers' needs and meet them where they want to run their workloads. Here we have some great resources for you to learn more about ACI, especially our ACI community site, where you can provide feedback or suggestions for new features. We always love hearing from the community and excited to hear what our customers want to see in the future. And with that, we thank you for watching our session.
Thank you.